This is a live web workforce challenges manufacturers face today. Presented by the Big M event coming to Cobo Center June 9th through the 12th, 2014. Visit bigemevent.com. Now here's your host, Paul W. Smith.
Thank you, Mark. The Big M event, a gathering of industry leaders and innovators to forge a new manufacturing future. Policy, education, technology, and partnership at the core. This event will happen June 9th through the 12th at Cobo Center. Put it on your calendar. Sharing proven practices and creative ideas to ensure the industry continues to evolve with forward thinking. You can join the conversation and be a part of the collective voice of the industry. For example, you're watching this webcast from www.bigmevent.com. That's bigmevent.com. And you can submit your questions to today's guest panel. You'll see where to submit your questions right below the webcast video screen. We're talking about a co-located event at the Big M called Rapid, which includes additive manufacturing and 3D printing. Our guests today are Debbie Holton, Director of North American Events and Industry Strategy for SME. Debbie, nice to have you back with us again.
Thanks, Paul. Good to be here.
We have Bryan Crutchfield, Managing Director for Materialise. Bryan, nice to meet you. And
good morning, Paul. Anytime
someone comes bearing gifts, I really appreciate that. We'll tell you about that. And the same goes for John Tenbusch, President of Linear Mold Engineering Incorporated. John, nice to have you here.
Good morning, Paul.
And finally, Brennon White, Manager of New Technologies, Phase Zero Seat Systems, Johnson Controls Incorporated. Nice to have you here.
Thank you, Paul.
Let me go right to you, Debbie Holton, as a Director of North American Events and Industry Strategy, SME. How is Rapid tied into the Big M?
Well, we're so excited to be bringing Big M to Detroit in June. And a very important part of the manufacturing process is what is really perceived to be a new technology, additive manufacturing and 3D printing. And since manufacturing is really all about bringing ideas to reality, it's a really dynamic way for manufacturers to do that is the new 3D printing, additive manufacturing technologies that have advanced so much in the last several years.
You know, this 3D printing, I hear about it and people are anxious to display it, but Bryan and John brought in some 3D work, and I'm not sure if we can get a good shot of this, or maybe you see it already on camera online here. John, start with the first piece that you presented to me just a few minutes ago. I thought it was made out of white chocolate, by the way. And would that be Bryan?
Yeah, actually, that's SME and Direct Dimensions were able to get us what's called an STL file, which is what 3D printers run on, of your microphone. And we took that, and with some creative help from some of our engineers and our software, we created what our version of the Hall of Fame Award of Broadcasting would be if it were 3D printed for you, Paul.
I can tell you it's a lot better than the real award. We'll let the people in Chicago know about that, because that's really spectacular. And it really was just something that you fed into your 3D printer, and it...
That's correct. So it feeds into the printer, and then overnight it builds through a process called SLS, selective laser sintering, and it takes powder a layer at a time and sinters it with a laser. And over the course of about 12 hours, it printed that piece you see there all in one shot.
And that's a resin, plastic?
It's a plastic resin.
Yeah, and then, so John, your linear mold engineering did it with the metal.
That's correct. Same technology as SLS, but just using powdered metals. And then a laser actually welds the powder onto the layer below, and you essentially grow a part.
And a fine golf tool as
Absolutely.
well added to the microphone there. Well, it's fascinating, and let's face it, Debbie, that's what the Big M is all about, bringing together the best and the brightest in manufacturing today. Highlight some of the unique features of our event, the Big M event.
Well, the Big M is going to be a really dynamic event. We have industry leaders coming. We have some innovation factories that are happening right on the floor, one of them dedicated to 3D printing and additive manufacturing, one for modeling and simulation, and one on cybersecurity, and some others that are really going to be dynamic live displays of technology for manufacturers that come to the event to see and get ideas.
And with ideas like this, and maybe if you could, Bryan Crutchfield, Managing Director of Materialise, just tell us a little bit about how Materialise is involved in additive manufacturing, 3D printing, and the importance of software for 3D printing.
Yeah, we develop software and services to help people exploit the power of 3D printing. People like engineering and design professionals, medical professionals, and even consumers. Our software suite allows engineers and designers to print their ideas and optimize the printing process. On the medical professional side, our Mimics Innovation Suite allows medical researchers and engineers to use a suite of tools to do engineering on virtual 3D models or actual 3D models of anatomy based off of medical imagery like CT or MRI or ultrasound. And then on the clinical side, we offer some clinical engineering solutions and software for physicians, surgeons, so they can plan their approaches or print actual guides to help them in the operating room and come up with that perfect plan before they ever enter surgery.
Most everything that I've seen up until today has been 3D printing with plastics, and the importance of John Tenbusch and his company as president of Linear Mold Engineering is Linear's focus on 3D metal printing, as you've shown us and brought the product. That's a very big deal. How did your company first start working with this technology and then branch out into this sector of the industry as a pioneer?
Well, we purchased our first machine to use in our tool and injection molding builds, and we were making small details, pieces used in the injection mold, and then companies started to discover that we had this technology, and we then take it and we started making parts for people, and now we've grown into the largest 3D metals printer in North America. We use Bryan software to do our data file preparation to go into the process, and we also use some of the stuff that he was talking about, his software for the medical world, and helping those guys develop implants or bone plates, all kinds of other things that are traditionally CNC machined or cast.
Well, and with the Big M event, and certainly Johnson Controls a big part of that when we all get together June 9th through the 12th at Cobo Center. Brennon White, manager of new technologies, Phase Zero seat systems for Johnson Controls. You guys are very excited about the use of 3D printing at Johnson Controls. Tell us about it.
Yeah, so basically back in 2011, I was a new technology manager, basically a technology scout, and we had been looking for new technologies. We found additive manufacturing was kind of a newer term at that point, and we expected it to be like a typical rapid prototyping that all engineers are pretty much accustomed to. We got kind of problems with it when we first started it because parts were brittle. But when I started looking back at it again, we realized the materials were much stronger. And then when we saw that you could print metals, a light went off. We said, you know what, this is something that you can use for manufacturing. You can make tools with it. You can make support fixtures, all sorts of things. So that's really the impetus for us getting moving on.
For the three of you, is that where the technology is headed at this point, basically?
I think the technology is headed in a wide variety of directions. There are any number of researchers that we work with through our software that are exploring bioprinting, right? The printing of tissues using stem cells or live body cells. They're exploring metal machines. They're exploring ceramics, plastics. So there's really been an explosion recently in the available materials that you can use in the 3D printing process, and that leads to a lot of innovations in a lot of industries.
They're even considering concrete and a lot of other areas too.
Yeah, we kind of think we've cracked the code with 3D printing with metal parts, and that we're actually making parts that are production parts, that there's no other manufacturing processes used other than the printing.
That's astounding, and that's frankly in a very short period of time.
That's correct.
Yes. So good for you, and you become the biggest and best at doing that at Linear Mold Engineering. That's a good thing. What do you guys hope to glean from the Big M event? And let me start with you, Bryan, there at Materialise.
I think it's going to be interesting to see how you can create an additive manufacturing or 3D printing ecosystem to bring together all the technologies and the companies that are available at the Big M, combine them with the technologies and companies that are available at Rapid, and create what Linear Mold has been successful at doing is that additive manufacturing shop or floor plant, right, if you will, to bring products to the market.
John?
Well, we want to mingle with these people so that we can glean new ideas from each other and how to take parts that are traditionally manufactured and take the next step and make them in a way that they can never be reproduced again. And just using this process. So it really opens people's eyes when they see all of the different parts and products that you can make with this technology.
And Brennon?
Well, you know, for us, it's about actually producing products. So we're interested in anything we can do to develop our products. So we're reducing development cycle times. So we're looking for those type of people that have those ideas to help us in that endeavor. But you know, the technology itself, we see opportunities for mass reduction, part consolidation, all of those things that, you know, are advertised. The question is, you know, how can we get it to that point where either we can make tools out of it, or a dream, which is probably 10 to 15 years off, is to make final parts for it. For us, anyways, you know, he's doing it today for the aerospace industry. They can afford a little more expensive part than we can. So.
A little jockeying for a better deal here, happening live on live. So talk amongst yourselves.
Well, we talk regularly.
We'd love to help you, Brian. You know.
You guys are doing a great job.
Oh boy, Debbie Holton, Director, North American Events and Industry Strategy for SME and for our Big M event. Are you hearing what you were hoping you would hear, and is there something else you're hoping they will take away from this?
Absolutely. I think that live dynamic of face-to-face opportunities with technology, with people who are interested in additive manufacturing, 3D printing, is really what we bring with a live event here to Detroit, and we're very excited to be in Detroit. Our Rapid event has been around for just about almost 25 years now, and even though the technology seems new, bringing this event to the Big M to create this dynamic interchange is really kind of a coming out party for Rapid, to find a new audience, to invite all those folks that are investigating the technology, and we're just really excited about, you know, folks like our friends here and all the goals and dreams that they have for being part of the Big M.
How does, John, how does participating in Rapid help your company stay competitive?
Well, we will mingle with these industry leaders in the aerospace, the medical world, and we want to be able to provide those customers with solutions to help them save money, to help them create parts and products that they have not ever been able to do in any traditional manufacturing methodology. You can lightweight aircraft engines by combining multiple parts into one piece. So
lightweight is, if of course, just finishing up the North American International Auto Show in Detroit. Lightweight is everything. In fact, if you were to pick a word, I think that summed up the show, it would be lighter.
Correct.
Right.
Everybody's trying to save weight everywhere.
Well, the consolidation of many different types of parts into one piece that can be grown at one time is a huge advantage for the guys in the aerospace world. They recognized this 7 or 8 years ago, and you know, one of the big boys out there making engines have jumped onto this technology, and they're leading the world in the use of this in the production of their engines.
Yeah, I mean, if you take a look at this part over here, it's got very open space cell structure on the base of it. That's what's known as topological design in the industry. And if you can get to that element, you essentially are able to eliminate the material that you don't need, keep the material that you need for the requirements of strength, and you can reduce typically between 20 and 40% of the mass just by doing that. But then there's the part consolidation that John was talking about. That gets you abilities to, you know, combine parts, eliminate fasteners, get to a point where you can actually consolidate functionalities too. So there's a massive amount of opportunity with this technology if you can get it to a point where you can use it.
Yeah, for us at Materialise to work at Rapid, it's enabled us to showcase our software and a design technology that we have that can enable people like Linear Mold and Johnson Controls to create those lightweight structures more easily, more simply, to utilize the technology to its fullest, and to sort of open their eyes on what's possible with 3D printing and additive manufacturing.
With that thought in mind, Brian, and as he mentioned, Bryan Crutchfield, Managing Director of Materialise, you made this wonderful little makeup for the award for me, and I appreciate that. But you said we put the information in, and then overnight, over a period of 12 hours, we got this. So when do we see it in an application that won't take that kind of time to create something like that?
Well, certainly the industry's evolving. There are new and faster machines every year at the show, and I'm certain there'll be several announced at this show.
pretty expensive machine.
They are fairly expensive, but in the realm of mass production, not that expensive, right? Injection molding machines and stamping machines and things of that nature is expensive as well. But it's an ever competitive industry. It's growing faster than some others, and slowly but surely the times are coming down. The materials are getting better. And we're able to see new applications where we never saw them before in jet engines, in airplane design.
Well, with that thought, John Tenbusch there at Linear Mold Engineering, and you made the little metal items, which is a big deal. How long does something like that take?
Those parts together, they're actually different materials, so they're grown in different machines, but about 10 to 12 hours for each individual item. And then there was some hand finishing that was applied to them to give them the polish. They don't come out of the machine looking like that.
Well, nothing comes out of a machine. Right. I've learned at being on the line, too, seeing where seating is made, for example, around the world. And I see, certainly, Brennon White, how Johnson Controls can see where this could be very useful.
Yeah, I mean, you have to realize that the speeds that we're talking about are only useful for tools for us today. For us to meet our production volumes, even in some of our niche divisions that we have, you need to get exponentially faster than you are today. However, like Bryan was saying, 3D Systems just came out with one system that was 7-fold faster than it was, the previous models. So the advancement of this technology is staggering. It's hard to keep up with.
It's an exciting time,
right?
It
Sure
is.
It is.
For especially for this kind of technology.
It is.
And there are some factories, Align Technologies produces roughly 40,000 pieces a day off of their additive manufacturing equipment. So it is growing in scale, and the possibilities are opening up.
Yeah, part size is a lot to do with that.
Absolutely.
They're basically making brace replacements.
Invisalign. He's talking about Invisalign, where they're making all of those retainers and orthodontic appliances through additive manufacturing. That's
is
a big
that right?
success story. Yes. Used to be molds that were sent to Mexico and cut a certain way, and they were able to take the advancements in 3D printing and make those all with that process, and it's been a great success story.
Another great example would be hearing aids. Phonak and Starkey and others are using 3D printed hearing aid shells now, and there are millions of those produced, where in the past you would have had a modeler that would have used clay and maybe sanded it by hand, and you would have gone back for custom fitting several times. Now they just scan either the ear canal or an impression of the ear canal, 3D print it, and insert the electronics, and you get that custom fit right out of the machine.
I don't mean for this to be not a political comment, but I guess it's when someone mentions hearing aids to me, it is the only item that I am aware of that, as the technology has come along and miniaturized them, the prices have not come down. And I don't mean to, I'm not putting anybody in a position there, but have you noticed that? I mean, all of this great technology, making them better and smaller and all that, but the prices still are pretty high.
Has it gone up?
It hasn't come down. And now the people that are using this kind of technology, maybe this will finally bring the prices down because baby boomers, more and more people are going to need those hearing aids. So it's just a thought whenever I hear about that. But additive manufacturing, the specific focus is on additive manufacturing. And I'm wondering if the automotive industry can do anything to improve the adoption of advanced additive manufacturing processes.
Yeah, so basically we have to get together and form a strategic vision. We talked about these ones that are being produced at a blinding pace. Well, they're being produced at a blinding pace because they're small. Now, if you take a look at the number of components that are that small on the automotive marketplace, it's very few. You're probably talking less than 20 to 40% of our products are in the small niche area. So what we're interested in is how do I get bigger and how do I get faster? And today the economics just aren't there for us. But with some of the research that we've been seeing and some of the opportunities that may be coming in the next 5 to 10 years, we think that we need to keep watch on this technology because it could get there.
But there are applications that are out there right now. For injection molding, as an example, we build inserts for injection molds and we put cooling lines inside of them. Basically, if you're running 1 million parts and you get a 20% decrease in your cycle time, then obviously it's a great value for the automotive industry today. And Linear is doing that right now, conformal cooling.
Yeah, they've helped us with many of those projects.
And Materialise, we have our own, we have a Rapid Fit, which is a 3D printing service that provides custom jigs and fixtures and quality inspection tools to the automotive industry and aerospace industry. And I will say some of our largest software customers are the automotive OEMs. They have some of the largest 3D printing labs in North America. They utilize them every day. In fact, they don't don't often have enough capacity for their needs. And they're using them to help them in part design, in car design, wind tunnels, things of that nature, so that they can optimize the car itself. While they might not be optimizing the parts with 3D printing, they're using it as a tool to optimize the overall system.
Well, it seems like for our Big M event, June 9th through the 12th at Cobo Center, Debbie Holton is the director of the North American Events and Industry Strategy, SME. You were right to key in on this.
Oh, absolutely. I mean, it's such an important technology, and it fits so well with the Big M, where we have modeling and simulation and design and smart factory, and all of this works together for this new manufacturing dynamic that's happening out there of more customized manufacturing. The advances in 3D printing actually are driving a more local and national supply chain for a lot of different items and parts, because people are able to make exactly what they need in their own neighborhood.
Well, let's talk internationally for a moment. I want each of you to give me your thoughts, your opinion, your input. How is the United States positioned to use additive manufacturing to its advantage? Are we ahead of, in the middle of the pack, or way behind the rest of the world?
It depends on the technology that you're looking at and the material source, right? Polymers, we've been at the forefront for a long time, but metals, we're way behind. In fact, you'll see most of the manufacturing machines in John's lab were probably German, right?
They're all German-made, yeah.
Germany's been way ahead of us on metals for a long time.
But not for long, John, if you have anything to say about it.
Well, that's for sure. I mean, the aerospace industry, the medical industry, you know, our industries here, those two items are so large in North America that we will very, very quickly catch up to the rest of the world. And, you know, they're already utilizing it. They'll be making knee implants where they'll grow you a custom implant, scan your good knee, mirror it over, grow you one that just save the doctor time in the operating room. No more parts sitting on a shelf. Everything could be just made to order. So much more efficient.
There are certain metals, alloys that must work better than others.
Correct. Cobalt chrome is one they've been using for a number of years, and we can grow that material. We have about 11 different materials that we can use in our machines: titanium, aluminum, Inconels, some of the super alloys that are used in the aerospace and the drilling into the earth.
Bryan?
I will say also the National Additive Manufacturing Innovation Institute, now known as America Makes, will also have a large presence at the Rapid event, and will challenge, you know, the North American manufacturing community to come up with those innovations to deploy 3D printing to keep us competitive in the 3D space.
If I may,
sure,
Paul,
of course.
the one thing that Johnson Controls is a little concerned about is the amount of investment going into research and development globally versus the United States. You know, America Makes, as you mentioned, has a $30 million stipend from the government to essentially, you know, jump technology from the research and development phase into a more production-ready phase. If you look globally, the Chinese, Singapore, Australia, they're all pumping gobs of money into this.
Lots more money than $30 million.
Yeah.
Oh, yes, hundreds of millions of dollars in each region. So
how does that change?
It essentially could be the thing that catapults them ahead of us as far as technology.
But how do we not let that happen?
Well, they have a lot of catching up to do. I was actually in China in April, and they're trying to throw a lot of both provincial and national funding at 3D printing additive manufacturing, but they really don't know much about it yet in China.
Well, let's not tell them.
Keep it a secret. But I think it really speaks well for, you know, the government's investment in manufacturing too, down in Youngstown at America Makes, where I actually served on staff there for about 9 months in the startup phase, that there is a lot of potential here and a lot that the industry can do as we gather together to move the technology forward. Folks like Johnson Controls, Ford, GM, Chrysler, they all have pretty dynamic 3D labs, as Bryan said, in this area. And, you know, the more that they can do together to kind of note those things that are advancements that are needed, like materials and machine capacity and speed, I think the market will respond and we'll be right up there with the best.
And we've talked, did you want to say something else?
Well, I was just going to say, and also, you know, the MEDC is a major sponsor, and they're supporting the Big M event, and, you know, hats off to them for bringing this event to the Detroit area.
Absolutely.
You know, we're sort of an engineering center of North America, and I think this is the first time in quite a while that Rapid and Big M have been in this region, and I'd encourage all the thousands of local engineers to come down and see what the technology offers.
And what I was going to bring it back to you, Bryan. Let's get back off the globe and let's come back regionally, and how your software is helping shape the industry and the future of manufacturing. right here in the Great Lakes region?
Well, one perfect example on the medical side is there was a young baby named Baby Kaiba. Many people may have seen the news articles. Some researchers at the University of Michigan, Dr. Glenn Green and Dr. Scott Hollister, used our Mimics Innovation Suite to design a resorbable implant. Baby Kaiba had a problem with his airway, and his internal organs would collapse his airway and he couldn't breathe. So they designed this, if you will, a protective cage that would go around the airway, and they used our software. They 3D printed it, implanted it in Baby Kaiba, and now 2 years on, he's acting as a normal child, and slowly the implant will resorb into his body once it's strong enough to support its own airway.
That's exciting, a bit of the technology. Any restrictions on this technology? Have you run into any limitations while researching it or even using it?
Well, I would say the biggest restrictions right now are size and speed. And until those take monumental leaps forward, it won't really be applicable for the automotive industry. But in other industries where the volumes are much lower, the annual usage is less, it's a great fit for making replacement parts in remote locations around the world. Great idea. You, instead of trying to ship parts that are logistically held up at the border, it might take a while to get there, you can print a part on site and use it right where you need it, rather than have them sitting on a shelf somewhere in Houston or Detroit.
Brennan?
So there are, it's actually a great time to be getting into this technology as it grows, because we are learning a tremendous amount about how to design for it. One of the elements that you really need to think about is when this part's being finished, how are you going to design it such that the part can be finished and can function as you intended? So those are things that we're teaching ourselves now to be ahead of the pack, so that we can basically, when we're ready to use it in full scale, we can do so. But we also are definitely using it on a regular basis for creating tools and more functional prototypes than we ever have before. So we are seeing a bottom line impact of this technology.
Excellent. Brian?
I'd say knowledge and training. Traditionally, engineers and designers have been taught to think in subtractive means, right? That you have to cut it, you have to stamp it, you have to assemble it, and getting them to understand the power through software or through services of how you can think in three-dimensional terms, how you can rethink how you would build this part, because you're not limited by geometry or the capability of the machine. And so I think the challenge becomes developing a training and knowledge base where people begin to think of what is capable in 3D printing, so I can add it to my toolkit.
Yeah, we've actually tried with some very exclusive design exercises, and we found that some of the softwares that were available will crash when we try to get as exotic as we want to be able to utilize topological design and have things that are ornate looking, because this is a great way to eventually have reduced, typically in a vehicle you put extra material around the product to make it look nice or to make it more touchy-feely for the occupant. But I might now in the future be able to go back to that wrought iron age, where I can make things very beautiful to look at and may not have to have the extra cover material to make it look extra pleasing. As
has been the case in our lifetimes with technology, we've gone from the crawling phase to the breakneck speed phase.
Right.
Yeah.
And so sometimes we get ahead. We get ahead of everything.
Absolutely.
But that's the way we grow, and why we do what we do so well in manufacturing, and why events like Rapid and Big M are important in the industry.
Exactly right, and especially on the knowledge and training side, that is a big focus for SME as we go forward. We hold the competencies and the body of knowledge for additive manufacturing, and we will also be offering a certificate program at the event where folks can come, take a review, and really kind of assess their knowledge in the industry and see how much expertise they really have. We feel it's important to set a standard for knowledge so that folks can really understand how broad a person's knowledge might be in the additive manufacturing space, and SME just we really strive to provide all the resources and knowledge that's needed to go forward.
John's dying to say something, and we're running out of time, so say it.
We talk about training. Well, Linear is actually doing linear technical training services. We're taking our OEM customers, we're bringing them in-house, we teach them how to design for the metals process. We also teach them how to run the machines and how to post-process the parts. I mean, it's all about the complete package. And Linear, I think we're the first company in North America really doing this with the technology that we're using in-house.
You're president, and you're in sales and public relations.
I do everything.
I think you're doing a heck of a job, too. Thank you to our guests. Of course, Debbie Holton, Director of North American Events and Industry Strategy for SME. Bryan Crutchfield, Managing Director for Materialise. John Tenbusch, President, Sales, PR, Linear Mold Engineering Incorporated. And Brennon White, Manager of New Technologies, Phase Zero Seat Systems, Johnson Controls. We'll see you at the Big M event in June.